Hello viewers, welcome to my channel Pharmaceutical. Today we are going to discuss another interesting topic from the subject cosmetic evaluations, that is about the measurement of transepidermal water loss. Now again, this is a very important component, transepidermal water loss, and is used for the assessment of various cosmetics pertaining to the skins. In the previous video we have also discussed about the sebiometer and coniometer. Let us now try to understand the principle and functioning of the transepidermal water loss. So before discussing the various devices which are used for the assessment of transepidermal water loss, first let us try to understand certain facts about the transepidermal water loss. What is transepidermal water loss? Actually, the transepidermal water loss is the most widely used objective measurement for assessing the barrier function of the skins in patients which are suffering from various skin problems such as atopic dermatitis. Now, you must have seen this function of the skin. The skin is actually acting as a protective function. It not only prevents the any external surface to external things to penetrate inside the body system. It is actually acting as a protective barrier, preventing the entry inside also, and also letting the body fluids from inside to evaporate outside also. So it is acting like a barrier. Now you must have heard about the corneocytes under the skin, which actually prevents the penetration, which actually prevents the loss of the fluids from the skin to the outer surface. Similarly, entry is also, so it is actually, there is a sort of balances being preserved by the skin, which actually uh, allows it to have its proper functioning. Now in case of certain disease like atopic dermatitis or psoriasis or like any skin disease, what happens is that this balance that the skin always maintains in a healthy person gets disturbed. Now due to this, there is excess loss of the water vapors from inside, excess loss of the fluids from inside our body to the outside atmosphere. Now when this is expressed in terms of a factor called transepidermal water loss. Now what happens when this transepidermal water loss factor gets elevated due to these skin conditions? This factor can be measured and assessed and quantified from various equipments based on this factor. So we are going to discuss in detail about the equipments which are being used. Now you can understand this assessment of the factor, that is the loss of water vapor from inside our body to the outside, is very important. It can also show you as the age advances or in the various disturbed conditions or in various disease condition, this transepidermal water loss gets elevated. So you can assess the parameter. Now actually, how, what is transepidermal water loss? What is the principle behind it? Now this transepidermal water loss is the quantity of the condensed water that diffuses across a fixed area of the stratum cornea to the from the skin surface per unit time. So when we assess the transepidermal water loss, it is at a particular location where we are actually applying the treatment during the skin condition. For the evaluation of the cosmetics, we select a particular area where we actually allows. Now, when we try to assess the quantity of the condensed water that diffuses across a fixed area of the stratum cornea, we are actually selecting a particular location inside the on the body surface, and we are trying to measure the gradient in the water loss which happens per unit time. Now, the water vapor evaporating from the skin is measured using a probe. Like you must have seen in the case of corneometer as well, or like in sebiometer, there is a probe which is being applied to the skin, and we allow it to detect through either through 30 seconds or for 1 minute. We keep it over there, and then we have the readings recorded on the monitor using that software system. So again, same things happen in this transepidermal water loss devices also. There is a probe which we actually put up on the skin, allow it to detect the value, and this value is being calculated and displayed on the monitor. Now what are the parameters? Actually, it is measuring the water vapor which is transmitting from the skin, and there are various sensors and probes which are actually assessing this gradient loss. Now what happens when we undergo any treatment? For example, like for the treatment of atopic dermatitis, you are using some cream, or like or any other skin conditions, then what happens, it alters the water vapor loss. because it is preserving it, it is trying to improve the condition. So this loss of water vapor is somewhat prevented, since the barrier property of the skin is being improved, it is being boosted up. So now this variation can be recorded, and you can check the efficacy of the treatment regimen in of that particular cosmetic. Now the transepidermal water loss can be measured using three devices. Basically, first is the open chamber device. As the name indicates, it's an open chamber whereby you are actually putting your anatomical part, or suppose you're putting your hand inside that, and then you're measuring the loss of water vapor, or like you are actually putting up the skin part inside that and measuring that transepidermal water loss parameter. Or it can be unventilated chamber. Unventilated chamber means like it is blocked from one side, it's a closed chamber from one side. Or condenser chamber device. Now this unventilated chamber device further got upgradation and advanced, whereby that chamber is actually created from the closed part, that we are going to discuss further in the slides. Now, transepidermal water loss varies significantly across different anatomical sites. What does it mean? Every skin is different, and different parts of our body have the different thickness of the skin. So does the water loss actually is different from the different parts of our body. So also it depends on the functioning of the sweat glands activity. How much active is your sweat glands? You must have acarine gland, apocrine gland. So how much active is in during the puberty phase? These glands are more active. Like which part of the on what is the age of the person, it also varies as per that. Now skin temperature conditions, like if the person is exposed to a very hot temperature, or like it is if the person is at a normal temperature, surviving at a cold, so this loss also somewhat varies with the temperature conditions. And corneocyte properties here refers to the condition of the skin. It is very dry skin, or it is very moist skin, or it depends on the hydration level of the skin as well. So skin barrier dysfunctions results in increased transepidermal water loss. So when the functioning of the skin is disturbed due to any disease condition like atopic dermatitis or any other condition, contact dermatitis, then what happens due to this imbalance cause, loss of the fluids happens more from inside our body to the outside atmosphere. This loss of the fluids results in the increased or elevated transepidermal water loss. Now, skin disease in which the skin barrier is disturbed, such as atopic dermatitis, contact dermatitis, psoriasis, ichthysis, are associated with we can say elevated or increased transepidermal water loss. Now, transepidermal water measurements consistently correlate with the percutaneous absorption of topically applied product. Now it is also related with the percutaneous absorption of the whatever product is being applied. Since it why we are studying the transepidermal loss, because we want to understand the efficacy of any cosmetic evaluation. We want to do the evaluation of any cosmetic product. We will be assessing this parameter regularly at frequent interval of time, suppose after 1 week or 2 weeks or 3 weeks. Thereby we can come to know whether the loss has been increased or the loss has been decreased. We are assessing the skin condition where the loss is at the higher level. Now when you undergo the treatment, this loss should be decreased. So if it is decreasing, that means it is the line of treatment is actually working. But if it is not decreased, that means whatever treatment regimen you are taking for the prevention of that particular skin condition, it is not working well on your system, and there should be some other sort of the treatment that should be sought for. Now, transepidermal water loss measurements can be seen as an indirect measure of skin permeability. Why do we say permeability here? Is because again, it is the loss of the fluid taking place inside the skin to the outside. So it's related to the permeability. It is not measured directly, but inferred from measuring the change of the water vapor density at the skin surface compared with a point farther away from the skin. So change in the water vapor density is the actual thing which is measured. The gradient is actually measured. Now, humidity gradient above the skin surface, that is proportional to the stratum corneum water loss. Now, it is stated in terms of water per square meter per hour. It is against per unit time. It can be measured using an open chamber device, unventilated chamber device, or condensing chamber device. Because of the sensitivity and variability in the measurements of transepidermal water loss, usually 3 or more readings are taken to calculate a mean value. So there are 3 types of the devices which I have told you. First is the open chamber device. As the name indicates, it's open chamber from both the sides, unventilated, closed from one side, and condenser chamber, whereby the water vapor gradient is being condensed at the same time. So it is in the advanced version for the unventilated type. Now when you are assessing at any particular moment, you need to take at least 3 readings and calculate the mean out of that. Now, when the skin, very important, when the skin has been treated by this cosmetic and pharmaceutical products, the skin secretion processes are hindered to a greater or lesser extent. Now, active agents that penetrate the skin results in an additional loss of the pressure. So, hindering the transepidermal water loss results in a swelling of the horny layer skins. The sensation that you feel after having worn rubber gloves for an extended amount of the time. So it is actually there is a loss of the pressure, which is resulting in a swelling of the horny skin layer. You must have seen when you wear the gloves, after some time you feel like suffocating yourself. So this is the feeling, this is the change in the change in actually transepidermal water loss values, which is resulting in the swelling of the skin layers. You must have seen the hands get swell, the skin conditions is different after you wear the rubber gloves for a prolonged period of the. Now this is the equipment which I was talking about. You can see, you can place the skin over here, skin or the body part. Then these are the sensors and in the probe which are actually measuring along with the thermometer part. So the microclimate is determined by the 2 moisture sensors. These are the sensors along with the thermometer positioned in a measuring head. This is the open chamber system. It measures the water vapor flow density, okay, per unit area, per unit time. Now each of these 2 sensors measures the partial pressure of the water vapor, and they actually measures the gradient between the 2 sensors, which is directly proportional to the rate of evaporation. Okay, so water vapor density, water vapor gradient is being measured by these 2 probes, sensors, and it is then computed through digital parameter on the monitor of the skin. Now you need to take at least 3 values to calculate the mean out of that. So open chamber device is a hollow cylinder which is placed in contact with the skin, and water vapor diffuses through the open chamber. Specially separated temperature and relative humidity sensors detect the humidity gradient. Now unventilated chamber transepidermal water loss device is like the upper end of the chamber is closed and resulting in a water vapor collecting in the chamber. The temperature and the relative humidity sensors detect the rate of increase of relative humidity. So what happens in the case of unventilated chamber is that the one side is actually closed. So what happens, the water vapors gets accumulated in that particular chamber, and the relative humidity sensors are actually able to detect the increase of the relative humidity. Third is the condenser chamber device. Now what happens, on the in the previous unventilated time, the chamber was closed from one side. Now above this chamber is a chamber is being created, whereby there is a condenser which is additionally placed. So apart from that, those 2 sensors, additional element known as condenser is being placed, which actually condenses the water vapor which have been collected from the chamber, enabling continuous computation of the results. Now, there are certain factors which affect this transepidermal water loss. Let us try to understand the certain factors. Skin care practices also affects transepidermal water loss. Now, what do we mean by the skin care practices? Like some people are more exposed to detergents, or like their lifestyle is like that. They are actually using or getting assessment of these chemicals more. So these agents like sodium lauryl sulfate can damage the skin barrier properties and leads to the increased transepidermal water loss, or increased permeability of the or loss of the body fluids, whereas emollients transiently occlude the skin and decreases transepidermal water loss. We are applying a lot of emollient, lot of skin creams on the, which are actually improving the skin conditions. So what happens when we have apply such kind of the creams, they actually occlude the surface, preventing this transepidermal water loss. So I think I hope I am clear that we need to prevent the transepidermal water loss for maintaining the skin conditions. We apply certain regimens, certain treatments, certain cosmetic creams to heal up the various skin condition like contact dermatitis or like psoriasis. So when we apply the treatment, we are actually assessing whether the water loss has been prevented or not, because during those conditions the water vapor is permeating more. So the your TEWL parameter, transepidermal water loss parameter, should be decreased as your treatment continues. So skin surface temperature and sweating additionally alters the transepidermal water loss. Studies have also been found that seasonal variations in transdermal epidermal water loss, and that TEWL is affected by the circadian rhythm and sun exposure. Suppose a person is exposed to the sun most of the period of the time, like more period of time, 10 to 12 hours, like guards. So their skin is different. Their skin has been hampered. So in that cases, transdermal epidermal water loss is more. TEWL parameter will be at a higher side. Now it has been found that TEWL has been shown to vary significantly at different anatomical sites within an individual. Yeah, that's true. TEWL is high at the palms, soles, axillae and forehead, and low at the calf and forearm because of the you can say variation of the lipid content in these areas. So the increased TEWL at sites such as the palms and soles is linked to the low sebaceous lipid content at these sites. Now regional differences in TEWL may also be due to differences in the sweat gland activity, occlusion, skin temperature, thickness and microvasculature, as well as the corneocyte size, maturity and shedding. Now skin conditions throughout the year also get varied. Also with the advancing age the skin becomes more dry, like so the as the condition, as the skin gets affected, so is this parameter. So like as you age on, this parameter actually increases. So you need to apply more for the emollients, more for the screen creams, because you are somewhere trying to improve the skin conditions. The corneocytes inside your skin gets more, and they actually occlude and prevent the water loss from the skin surface. Thank you so much for watching my video. Please do like, share and subscribe my channel Pharmacypedia. Happy learning. Please do comment in the comment box. Thank you so much.